Hello everyone and welcome back once again. In today's session we are going to be discussing more about memory, setting up memory and memory management in chatbots. So I think if you have interacted well with chatbots, I think you have come across one thing that is most common when you are building chatbots, and that is memory management. And one tool that is specifically designed to help us achieve this feat is LangChain. But before we dive in and start seeing how to build or embed memory in our chatbots, let's first try to understand what do we mean by memory. So I just did a quick dive or a quick search about LangChain memory, because we're using LangChain. So LangChain memory, so these are modules that actually enable language models to retain context and information across multiple interactions. So when you are actually chatting with the large language models, one thing that I think of late, one thing that comes into mind is that the large language models are able to retain context. That means when you are chatting with the model, you're able to make references to the previous chats, and this is quite synonymous to how actually people converse. So we might be engaging in a discussion. Then once in a while, I might be making references to the previous conversations that we have been having. So the same thing or the same feature happens when you are embedding chat, when you are actually embedding a memory into chatbots. Okay, so actually this is important, because when you are building the conversational AI applications like chatbots, without memory, each interaction will be treated as a new conversation. So we want to avoid that, so that we are able to interact well with these conversational AI applications. So to avoid the application from forgetting what we have been discussing, so we need to embed memory so that we're able to keep that conversation going. So without this, leads to a disconnected and frustrating user experience. So we want to avoid that. And by doing so, we are only going to achieve that by actually embedding memory into these AI applications. Okay, so with LangChain, we can consider this as a tool that we can use to actually build these memory modules. So the key aspect with the LangChain is about the persisting state. So memory modules are responsible for storing and retrieving the state of a conversation or an agent between calls, allowing the large language model to actually remember the previous interaction. So that is actually the main goal that we. That is the main goal of actually using the memory modules. Other things about the contextual understanding. So by us providing the access to past messages and relevant information about the conversation that you're having, the memory helps the AI to actually understand the current conversation in its proper context, leading to a more accurate and relevant responses. So that means if I'm going to make actually a reference to a previous comment, then the model is able to retrieve that. Then now whatever response is going to generate is going to be accurate. So with LangChain, I think we have this. I think from the software engineer guys, we have the stateful and stateless applications. Okay, so if you're coming from with the background of software, so we have the stateful and the stateless applications. So when you're talking of stateful applications, stateful systems maintain information about the past interactions. So with us embedding memory within our application, is that we're making our application to be stateful, and by doing so, we're able to remember the previous or the past interactions. But if you don't have memory embedded within your application, then your application becomes stateless. That means every conversation that you're having henceforth becomes the model actually considers that message to be a new interaction. Okay, so we have the different types of memory when you are dealing with the LangChain. So we have the conversation buffer memory. So this one stores the entire conversation history. So whatever conversation you are having with the model, so with the conversation buffer memory, this stores the entire conversation in history. So the conversation buffer window memory, so this stores the most recent key messages to manage context length and cost. So this one is good if you want to retain the entire conversation, but if you want to retain as the most recent conversation of messages, then you have to set a parameter k, and this parameter k is the one that will guide the memory system to which messages is going to actually store. So we might be having a conversation, then picture this, that you are my friend and we have been having a conversation. We are now in 2025. Okay, so with this one, setting the recent parameter, the parameter k, that means we are only going to remember, let's say you're setting k to be 6 months. So we are only going to store the recent messages up to the 6th month from now. So something like that. Okay, so that is the conversation buffer memory. So we're only going to store recent k messages, and k is the parameter that guides us or tells us to which up to certain period are we going to actually store these messages. Then the conversation summary memory. So this one summarizes the conversation history to provide a concise overview of what you have been talking about. So as you continue to chat with your model, it's just summarizing as the new chats come in. So it just summarizes to provide a holistic overview about the conversation itself. Then you have the conversation summary buffer memory. So combines the summarization with the buffer to manage the context length. So this one is essentially works similar to the previous one, but since you have the recent k messages, so you're only going to the k messages that you have been storing. So you're going to only provide summarization based on the stored k number of messages. Okay. Then you have the entity memory, focuses on tracking and remembering specific entities mentioned in the conversation. So remember, if you have specific entities, let's say we are talking about the different continents in the world. So we can take the continents, the different continents as the entities in our conversation. Okay, so picture like a brain trivia, something like that, where you have to remember a specific consider something like a spelling challenge. So you are given a word, then you are told to spell something like that. So with the entity memory, you are only able to remember the specific entities that are important in that conversation. Okay. So when you're building this, generally when you're building the conversational AI applications, it's very important, unless it's a stateless application, but it's very important to note the type of memory that you're going to use, so that you're able to satisfy your needs. So all these have their advantages and disadvantages, or the merits and the demerits. So again, depending on the application that you're building, then I think that one will define which type of memory that you are actually which type of memory that you will be using. So I think I've tried to just do a quick overview of memory and all that, and what we're going to be discussing today. So enough of talking, and let's now jump into the coding part, and let's see how we will embed memory into our chat application. So summary of the tech stack that we will be using. So I'll be using LangChain. LangChain will provide us with the tools to build or embed the memory component into our application. Then now we have Ollama. So I'll be building this locally. So Ollama will be our friend for this. It contains all the embedding models and all the some of the LLMs that we can use. So we can just build this locally as our POC, just a proof of concept. Then Gradio for dashboards. So if you want to generate dashboards and all that, we can use Gradio. And then scikit-learn offers us some when you want to work with scientific library. So things to do with the cosine similarity, calculating a numeric calculations, all that NumPy. Then we just need to maybe for that we'll rely on scikit-learn. Okay. So these are the libraries that we're using. As you can see, most of these are libraries that deal with the LangChain. So we'll be working with unstructured data as sample of text. So this one will be important for that when we will be working with when we'll be actually doing the embeddings. Then the character text splitter comes in. Then we actually need a vector store to actually store the embeddings that we'll be generating from our text. So that is the Chroma vector store that we're going to use. And then we have the conversation retrieval chain, because we'll be retrieving when we build a model, then there's that sequence of messages or how they are being stored. So for us to retrieve that, and then we'll be using the conversational retrieval chain. Then we'll be using the conversation buffer memory for this part. Then I think recently, LangChain have introduced the chat message history. So when I was preparing this, I realized that chat message history is the new one. I think we'll just use this one, but I'll also show you where we're coming from before we actually embed use this one. Okay. Then for how AI message, human message, then for us to actually interact with the Ollama, so we need the Ollama library. So here we are going to access different LLMs and also the embedding models. For me, I think these are the models that currently I have. So I have the Quen, the DeepSeek, and the Llama 3.2. I think we'll be using the Llama 3.2, but you can use whatever model that seem fit for your case. Then for the embedding models, I'll use the BGE large. I think this one is quite a good model when it comes to embedding. So I really prefer using that one. Then prompt templates, NumPy, cosine similarity, because when you are doing the conversation, I'll try to retrieve the messages, calculate the cosine similarity to see if the message that we are sending now has some similarity to a previous message. So if there is some level of similarity, then we won't need to do the embedding. We just retrieve whatever response was generated in the previous message. Then a Gradio for that, request library for. Okay. Now, so these are the libraries that you're going to use. Then the first thing is about document loading. So for my case, I have a simple, just a simple text. And for this text, we're talking about the pyramids of Giza. So picture this, that you are touring. You're touring the pyramids in Egypt, and then you just want some technical knowledge about the pyramids. Okay, so we are going to build this just a simple chatbot that you can actually ask more questions about the pyramids. Okay, so this is our document. So I've created a variable document, and this will now house our text. You can see it's quite lengthy. So this is the information that we are going to build the chatbot on top of this. So this is our document. Then from there, we can just maybe clean up the existing files. So I just want to rerun this afresh so that we create a new document for this. Then we can clean up the existing files. Then we can just load the document itself. So as a new document. So once you run that, you can see the document loaded successfully. So document length, and then just a little bit content preview. So the pyramids of Giza, ancient. So all that information is all about all this. So just a brief overview to see if you have actually loaded your document. Okay, So once you get this, you can see that so for the content preview, you're just printing like the first 200 characters, just to see if we have actually loaded the document. So this means that we've actually prepared our document and loaded it. Okay. Now, the next thing after preparing our text, similar or analogous to preparing your data, something like that. So we need to do the text chunking. Okay, so we need to chunk our text. So chunking is about splitting the document into manageable chunks and then storing those chunks. So you might ask, or we might ask, why are we actually chunking? So chunking is it's a technique that when you're building chat applications, I think it's a technique that you have to do so that you're able to split text into chunks that have semantic similarity. Okay, so we're doing this so that we're able to improve on our retrieval. So that's why we need to do the chunking. So for that, we need to split the document into chunks, and for that one, I'm using the character text splitter. Then for the chunk size, I'll be using about 500. Then the character overlap is 50. So 50 small overlap, so that we are able to maintain continuity in our documents. Okay. Then we now here is like we initialize the text splitter. Then the text splitter, so split documents as a function. Then we pass in the documents. Okay, so the documents. So this one is the document. So we loaded our documents to this variable. This is the one that we are passing here, so that we're able to do the splitting documents according to the instructions that we provided earlier. So once we do this, we can after the text splitting, we can just display a few chunk examples. Okay, so document chunked successfully, number of chunks created 16, average chunk character size about 363 characters. Then sample chunks, you can see chunk 1 about 50 characters, chunk 2, chunk 3. Okay, so we have tried to split our document into chunks. So this one so instead of dumping the entire text into your LLMs, I think chunking also so instead of just dumping your entire corpus or document corpus into LLMs, which is also a strategy that you can use, but with the dumping the entire corpus into your LLM, so LLMs have a context window. So I think let's say context window. So these large language models do have a context window. So, and the context window is a sort of like a working memory for the large language models. Okay, so the reason as to why we are chunking instead of dumping all our documents into a large language model is that with the chunking, you don't necessarily dump the entire documents into your large language model, but the inverse of that is that you can have a huge corpus of documents, and dumping all that into your LLMs, then you might exhaust your working memory, and then the response that you might be getting based on that can be quite low. So for us to actually prevent that, so we can just create chunks. Then the chunks have a semantic meaning. So depending on the query that is coming from the user, then we're only going to retrieve a section of the chunks, and then those chunks will now be dumped into the LLM working memory, and that will be used to actually generate the response. Again, I do believe that the quality of the response decreases with the increase in the number of tokens that are actually dumped within the working memory of the large language model, because you might miss some of the required nitty-gritties during your response. So that's why we need to actually chunk. So with chunk, you can chunk your entire corpus. Then you'll have an infinite access. Because you'll have an infinite access, that means the chances that you dumping the entire content into your LLM is quite low. So you only be working with what is actually important. Okay. Then from that, we have the vector store. So we need, after we have done the chunking, we need to convert the chunks into numeric representations. Remember, computers don't understand natural language. So we need to use the embedding models to actually convert the chunks into vector representations, and then store those embeddings into our vector store. So this cell actually sets up the vector store. So we are using the Ollama BGE large as our embedding model. And then I think we are using ChromaDB as our vector store. So with the ChromaDB, this one you can actually create ChromaDB locally. Okay, so I don't need to create I don't need to create a remote vector store. So I can just create this one locally, then store my embeddings, and I can just query from there. So here we're just checking if the Ollama server is running, so that we're able to access the models. So the models that I showed you earlier, this one's here. So we need to make sure that our server is running for us to access all those models. Then from that, we need to clean up any existing vector store. So ideally, you don't need this, but for the demo purposes, I just want to clean any existing vector store. Then from that, I will initialize the Ollama embeddings. So you can see I'm using the BGE large as my model. Then I'll use this one to actually create my embeddings. So vector store, Chroma is my vector store. Then from documents, so I'm passing in my text. And also so it takes the text and embeddings as the parameters. Then we'll be passing in. So we'll be passing in, I think, the text. So the text is I think we did save our documents. The document that we split, we did save them into this text as a memory. So this one contains all the texts. Then we are passing that the text. Then So the text. Then the embeddings, you'll be using the embedding model, and then the ChromaDB path. So that is the path that we have used to. So that is the vector store that we have created locally. So we are passing the path here. So once we do the embeddings, so these are the texts to do the embeddings. This is the model that we are going to use for the embeddings. And then this is the path where we are going to store our embeddings. Okay. Then once we are done with that, Ollama server running, initialize Ollama embeddings. Then vector store created successfully in memory. That's why we provided the path to that. Then the vector store created successfully. The vector store contains 16 embedded chunks. Okay. I think the 16 embedded chunks are similar to the number of chunks that we actually created. Okay. So if there is a mismatch, then it might be making some errors. Okay. Then I just did a test retrieval. What is the height of the Great Pyramid? I found 2 relevant documents. The most relevant document is that the pyramid of Khafre, built by Khufu's son, appears to be the largest. Blah blah blah, all that. Okay. So this is just a test to see if my vector store is actually configured appropriately. Then once we have prepared our data, cleaned our data, stored our data, then we generated embeddings for that data. Now we need to set up the memory implementation step, okay, and something to do with the similarity checking. So similarity checking, I'll show you why I'm using similarity checking for this. Okay, the first thing is that we need to initialize the conversation memory. So for my case, I'm using the conversation buffer memory. And then I'm passing in these parameters. So the memory, the chat history. Then for us to return message has to be true. Then the output key will be the answer, something to do with the response. Now, I will be using the cosine similarity. And then if I'm going to use the cosine similarity, I will be comparing the different queries from the user. That means that if I asked a question, the first question and my fourth questions have a higher or have some they are let's say they are matching to a degree. Let's say for my threshold it's about 85%. Let's say they have a 85% similarity. Then I won't necessarily need to actually embed the query. I'll just go back and retrieve the message that was actually the response that was from the previous question that are showing some form of similarity. Then just reconstruct that answer and deliver that answer as the response. Okay, so get the embeddings from the query. So this one we are getting embedding from the query using the same embedding models that we have been using. So this is the query. You can see you're passing in the query. So this is the query or the question that the user is actually asking. Okay, then we are checking for similarity. So check if the current query is semantically similar to the previous query. So this is very important, and you can see the arguments that you're passing here. It's about we are passing in the similarity threshold, because we're going to use this one to actually check if the current query is semantically similar to the previous query. So maybe one question that I may ask you is that why are we not using the keyword? We are most concerned with this semantic similar and not the keyword. Okay, the reason as to why we are not using the keyword, similarity here is because with the keyword we won't get the intention or the intent of the user when they are actually asking a question. Because in a conversation, whatever question I'm asking, it has to have an intent. Okay, and for us to actually capture the intent from the user, then we have to compare the different queries semantically, so that we're able to see which queries are actually similar and group those queries together. Okay. Now, if the similarity is greater than the threshold, then we just return the previous answer. That means we won't necessarily need to embed that query. So we just need check if the similarity is greater or equal to the threshold, then return the previous answer. So picture this, that you have built this nice application and the embedding costs are quite high. Okay, so if I want to cut on the embedding costs, then I have to establish such a function, so that I'm able to reduce significantly in terms of embedding costs. Okay, then if not chat, then we just return none. Then normalize current query. Then we need to extract the previous queries. So then we need to actually extract it. Let's get embedding query. So normalize the current query. So this one, current query, lower strip. This is just some formatting step. So we are stripping maybe. Then we make sure everything is in lowercase. Then we pass in the current query. So passing to the function, get embeddings from the query. So this function, so that we're able to actually get the embeddings. Okay. Then we can extract the previous queries plus the answers. So the previous queries and the previous answers. So we are storing them in some sort of a list. Then for I in the range, so the chat history. Then if I previous queries, then we append, and also the previous answer. So this is just a for loop that we are creating to actually extract the previous queries and the answers. So that if this is semantic similar, then you don't need to do the embeddings. You just return the previous answer. Then we can compute the similarities with the previous query. So this one we returned the previous query. Then here it's all about us doing the computation, and they're using the cosine similarity. I think this one is the best way, so that we're able to calculate the semantic similarity with respect to the threshold that we provided here. Okay. Then if a strong match is found, then just reuse the answer. I think that one is well elaborated as of now. Okay, so the memory initialized with the conversion buffer. So when I was preparing this, I actually encountered this I will not say it's a problem, but just some sort of a warning to tell you that I think LangChain has actually deprecated the conversation buffer memory. Okay, so we are going to use the new one, which is the chat message history. Again, everything remains the same. The get embedding query, the chat check similar queries, then normalization for that, extracting the previous. So everything just remains the same. So the only thing that we have actually changed is how we are actually using the LangChain's new chat message history. Okay. So once we are done with that, so we can set up everything. So memory system initialized, the chat, then the similarity threshold of set is 0.85. Again, the higher the similarity threshold, that means if you put or if you set the similarity threshold to be higher, that means that the questions that or the queries have to be high in terms of they have to be quite related. That means you might miss out, or you might if you make it high, that means your system will behave in the normal manner. That means that there's higher threshold that has to be met for us to say that this query is semantic similar to a previous one. Okay, but if you put it or if you set it low, then that means that that all queries might all be the same. Then you might not be actually the embedding process might not, again, you might not be needing the embedding process, because if all queries are the same, then you don't need the embedding module. Then the idea of you building the chat app ceases to exist. Okay, so you need to vary this one accordingly. So find the sweet spot. Okay, then once you're done with that, then we can actually set the LLM and the LangChain setup. So here we are using the prompt template. So consider prompt template to be like something to do with the guardrails on how you want your LLM to be responding. Okay, so this is the prompt template. You are a knowledgeable guide for the pyramids of Giza. Use the following context to answer the questions. Okay, then the prompt template takes the prompt template that you have set here, and then the context as well as the question. Okay, the context and the question. So it takes the context and the question so that we are able to give a response based on that. Then we can initialize our LLM. So I'm using the Llama 3.2 latest as my large language model. Then we can just do a simple test. So test a response. So hello, how are you? Then we can this is just a test to see if we can access our large language model. Then previously we are using the retriever, so vector store as a retriever. So in terms of K, these are the number of documents, the maximum documents that we are going to be retrieving. Again, this is you can consider it as a hyperparameter. Yeah, consider this as a parameter that you can toggle so that you can increase. So the more documents that you're having, maybe the greater or the good response you're going to get from that. Okay, but again, if you have more documents that you're retrieving, then you tend to lose some meaning, because you have more documents, and then you tend to lose the quality of response tends to decrease because of the more documents that you have to pass through and do the analysis. Okay, again, and if the K is quite low, then you might be missing out some of the documents that also contain information based on the query of the user. Again, this one is just a parameter that you actually need to vary, okay, time with time. Okay. Then the function that will generate our response. So the main function to get the response. So it checks the memory for similar past questions. If no match, performs the RAG retrieval and generation. The normal retrieval and generation. Again, it saves the new question and answer to memory. So that is a function that will help us to actually achieve that. Okay. So then we can just run that. Then you can see we have actually set up that. So we need to actually do some testing to see if we are actually getting the required responses that our model that we require from our model. Okay, so these are some of the test questions. So you can see I have about 5 questions. Then question 2 and question 3 are quite similar. Question 2 and 4 are quite similar. So what is the height of the Great Pyramid, and which pharaoh built the largest pyramid? Can we say, okay, in my assumption, you can say that they are quite similar. So let's see if we calculate the cosine similarity, if we'll see if we are going to get a higher threshold, okay? Then, so just clear memory before starting a new test run. Again, so once we run this cell, then you can see testing memory functionality with sample questions. So question 1, how tall is the Great Pyramid? So you can see we have generated the responses, and the Great Pyramid of Khufu originally stood at 1456 meters, about 481 feet tall. Okay, so how tall is the Great Pyramid, and what is the height of the Great Pyramid? So you can see there's some semblance in terms of these questions, and then in terms of the response, you can see that we got a memory hit. Similarity is 0.97, which is actually greater than 0.85. So this is the threshold that we set. Again, so instead of actually doing the embeddings, going to the vector store, doing a similarity search, so instead of that entire process, we can just return our previous response. So you can see the response that we are returning is the one that we got earlier. So you can see actually our model is actually attaining whatever we set it, or how we set it out to actually respond. Okay, then who built the Great Pyramid? So you can see who built the Great Pyramid versus how tall is the Great Pyramid. We are getting a 0.7 similarity, 0.7 in terms of the similarity, or you can say that these two queries have a 70% similarity. Okay, because this one is less than the threshold we set at 0.85, then no match found. So we'll have to actually regenerate, do the embeddings, do the similarity search from the vector store, and then use the response to get the relevant chunks, and use those chunks to actually generate our response. Okay. Then which pharaoh built this? Then you can see generated the response. So the Great Pyramid of Khufu was built by Pharaoh Khufu. Okay. Then what's the Great Sphinx? So you can see again it's actually checking with how tall, who built, and which pharaoh built the largest pyramid. Okay. You can see that no close match was found, so it has to perform the retrieval and the generation. Okay. So you can see actually we're able to achieve whatever we set out to do, because whenever we have queries that are semantically similar, so instead of doing the retrieval and generation, we can just return the previous answer that is stored in memory. So you can see whenever response you are asking your model, it was able to store the responses. If a similar query, a similar query was asked again, then we just return the previous response. Okay, so you can see up to now our model is actually functioning as intended. Okay, so I just wanted now to finalize this by actually creating the Gradio frontend. So this is a Gradio. So Gradio for data scientists, you can say it's a shortcut for us to actually not write the HTML and CSS code for this. So you can just use a Gradio or a Streamlit for that matter. So it has actually abstracted the required CSS, HTML, and all that. So you can just build your MVPs, your POCs easier and better. So for this one, we are using Gradio. So chat function that integrate with Gradio chat interface. So here's the chat interface. Chat with memory. Okay. So this is just how we create the Gradio itself. And then we can now launch the Gradio interface. Okay. So this is the launching part for that. So once we launch, I'll just click this so that it takes me to another cell. So this is I can call it a front end, okay? So the pyramids of Giza expert chatbot. So welcome to the pyramids of Giza expert chatbot. So the features or what this chat is actually built on: RAG system, memory integration, and smart responses. So you can ask me okay, so you can ask me about the construction details, about pyramids of Giza. Okay, so let's ask our model this question. Or I can just copy this, then just create a new notepad. I don't want to. So how tall is the Great Pyramid? So I can just type this one here. So how tall is the Great Pyramid? So how tall is the Great Pyramid? Then we can wait for a response. You can see the Great Pyramid of Khufu originally stood at 146 meters, 481 feet tall. Okay, let's ask the second question. So who built the pyramids? So we can just type this again. So who built the pyramids? So you can see from the first question, it took quite some time before I was able to get a response. Okay, so we can who built the pyramids? So this one took about 8 seconds. So according to the provided context, they were not built by slaves, but the workers who lived by the nearby settlements. Okay, so so this one took about 8 seconds. I want to reframe this question. So how tall is the Great Pyramid? Okay, and say maybe how or what how high is the pyramids of Giza? Okay. Let's see if you're going to actually get a similar response. Don't know why it's taking some time, but we need to be getting a response similar to this. We can restart this. Maybe if you can restart it again. We have launched it fresh. Let me terminate. I think that's okay. So let me So running server. But I can just, although I'm having some challenges, but let's use this one. So the pyramid of user question, how tall is the Great Pyramid? So this one is focus about 11, 12. Okay, so you can see user question, how tall is the Great Pyramid? So you can see how tall is the Great Pyramid. This is one from our previous responses. So returning answer that was stored in memory, the Great Pyramid, this one here. So you can see, let's try out another question. What is the great sphinx? Which pharaoh built the largest pyramid? Let's try ask a question. The largest pyramid was built by who? Or some sort of a question. So let's see if there will be, if there's going to be a match with this one, so that then just if the response is going to almost match. Okay, the Great Pyramid of Khufu was built by Pharaoh Khufu. Then let's look at these statistics again. Which pharaoh built the largest? So you can see, so the question, the largest pyramid was built by who? You can see there is higher such similarity with this question, which pharaoh built the largest pyramid? And by so, instead of actually retrieval and generation, we just return the previous response. The response is this one, the Great Pyramid of Khufu. I think we have there's a question previously we have answered that just returned this response. Okay, so that's it. That's it from me today. So we have seen, just as a summary of key takeaways of what we have done today. So we are able to actually build a conversational AI application that answers questions with respect to the pyramids of Giza. So with our application, we are able to embed a functionality, a memory functionality using a LangChain. And with LangChain, it has enabled us, or it has enabled our model to turn from being stateless to stateful. That means it's able to remember the various interactions that you have been, the various interactions when working with the chat application. And from that, we have seen that actually we're able to return a response. Just a minute. I think it's okay. So with that, with us building that or embedding that chat functionality in our application, we're able to actually make our chat application to be, as I prefer, as I said earlier, we're able to make our chat to be stateful. It's able to remember the previous interactions, and by that, I think we set from the goal that we set previously when we started this. From that, I think we're able to achieve that. Okay, so yes, this is how we can actually convert the stateless applications to be stateful, and in whatever chat applications that you will be building. I think using LangChain, of course, there are other techniques that you can actually apply, but this is just like an introductory, so that you are aware that this is how you can actually build these applications. Okay, so maybe with me, I tried with the, I think with the LangChain. I think the new one, ConversationBufferMemory. I think the chat message history. I think this is the new one. This one is the new one from LangChain. I think the conversion buffer and all that. I think they also have how you can actually using so you can see we have the different ones. So we have like using with the runnable with the message history. This is the article that I want. So migrating off conversation buffer memory or a conversation string buffer memory. Okay, so this is the new setup if you want to actually integrate memory into your applications. Okay, so I think that's it from me today. So we'll be doing more of this, looking for the different sort of functionalities that we can be embedding into our existing applications that we have been building, and or trying to demystify the different concepts, especially when you're working with the RAG systems, agents, and all that. Okay, so again, thank you for your time. Subscribe to the channel and see you in the next one. Bye bye.